Hi everyone, and welcome to ScienceGem, your go-to channel for clear step-by-step walkthroughs of GCSE science exam papers. Whether you're aiming for top grades or just trying to boost your confidence, I'm here to help you break down the questions, understand the mark schemes, and learn how to answer like a pro. So, let's get into it. Today's walkthrough is GCSE Combined Science Trilogy, AQA, Higher Tier, Chemistry Paper 2, and it's 2020. Question 1. This question is about the Earth's resources. When most fuels burn, carbon dioxide is produced. Propane is a fuel. Balance the equation for the combustion of propane. So, let's have a look. So, on your right hand side, count up oxygen atoms here. 3 times 2, so that means there's 3 lots of these, so that's 6 oxygen atoms here. Here, you've got 4. That gives you a total of 10 oxygens. So, what number would I put on the outside of O2 to give me a total of 10 oxygen atoms on my left hand side? Good, 5. Describe the test for carbon dioxide. Give the result of the test. Well, the test is I need to use lime water. The result turns cloudy. Or you can say it turns milky. Or you can say it turns white. Okay. Propane can be cracked to produce propene and hydrogen. So cracking is where we use heat to turn large alkane molecules into an alkene molecule and a smaller alkane, or it could be hydrogen. So propene also has 3 carbon atoms. Propene is an alkene. So even if you don't know the formula, it's not the end of the world, because look, if I take 2 hydrogens off, that leaves me with 6. So I know that is 6, and I know it's 3 carbon atoms. First of all, because it's prop, which means 3. And also, I haven't got any carbon atoms here, so that must be C3. 1.4, test for hydrogen. A lit splint or a burning splint. Result, burns with a pop sound or a squeaky pop sound. Propene is an alkene. Describe the test for alkenes. Give the color change. So, testing for alkenes, you should know that it's bromine water. Color change, so the initial color of bromine water is orange, and if an alkene is present, it will go colorless. Some students investigated the effect of temperature on the rate of reaction. So this is your rate of reaction required practical. Sodium thiosulfate, hydrochloric acid, this is your method. So use a beaker, measure 50 centimeter cubed of heated sodium thiosulfate, measure the temperature of the room, put the conical flask on a black cross, drawn on a piece of paper, start your timer. Use the same beaker to measure 10 centimeter cubed of HCl. Stop the timer when the cross is no longer visible, and the student repeated the experiment at a different room temperature. The method contains errors, and it does not produce accurate results. Describe a method the students should use to produce accurate results. Do not write about safety precautions. Okay, so for 6 marks. Right, so they haven't spoken about how they're measuring the hydrochloric acid. So use a measuring cylinder. To measure 50 centimeter cubed of sodium thiosulfate. And then no mention of, how there should be a fresh measuring cylinder to measure HCl. So use a different to measure 10 centimeter cubed of HCl. And then it says start the timer here, but it should be start the timer when the acid is added. So they start the timer here, then you add HCl, then you stop the timer, which is obviously incorrect. So start the timer when the acid is added to the conical flask, whilst then it goes to stop the timer. The student repeat the experiment at different room temperature. So stop the timer when the cross is no longer visible. So they've got that there. Record the temperature of the solution after the acid is added. So I've got 4 bullet points, just need to have 2 more. Oh yeah, another really important one, so throughout the experiment, use the same volume of sodium thiosulfate and HCl, and then repeat the experiment at different temperatures. So I've got 6 bullet points there, which should get me 6 marks. And I have mentioned this in some of my previous videos. So they've given you a whole page to write an answer. Don't think you have to fill out every single line. You don't have to. Just focus on the fact that it's 6 marks. You need 6 bullet points. Once you get to that stage, you move on. Don't start waffling, okay? Don't just fill out the lines for the sake of it. You don't need to do that. Right, so student recorded the loss of mass from their apparatus at 40. Okay, so be careful. This is a graph to show loss in mass, obviously your negative values, and you've got time in minutes. It says calculate the mean rate of reaction between 1 minute and 3 minutes at 40. Well, that graph is for 40. So what we do is we go to 1 minute here and we read that value off. So remember we're going down, it's negative, so 0.15, 0.16, 0.17, that's 0.18. So for 1 minute, it's 0.18. Let's do the same for 3 minutes. That is 0.33. Okay, so let's work out change in mass. That's 0.33 minus 0.18. That should give me 0.15. That's my change in mass. Time in minutes. So 3 minutes minus 1 gives me 2 minutes. 0.15 over 2 should give me 0.075. Draw a curve on figure 2 for the results you would expect at a temperature of 50 degrees Celsius instead of 40. So at 50, the reaction will proceed faster. The line should be steeper. So what you do is, the graph should look the same, but sits below that line. and it should level off at the same point. That wasn't fantastic, but it should level off at the same point as the last part of that graph. So this question is about pollutants. Wastewater has harmful substances removed before being released to the environment. Wastewater, okay, complete the sentence. Agricultural waste water requires the removal of harmful microbes, or you can say pathogens, or you can say bacteria. Industrial wastewater may require the removal of harmful chemicals. So wastewater, once the wastewater has been screened for the removal of big objects and grit, it comes into huge tanks called a sedimentation tank, and the wastewater is allowed to sit there. At the bottom you have all the solid, which we call the sludge, and at the top you have the water, which we call the effluent. This question is saying, how is sludge treated before it's released into the environment? We add anaerobic bacteria to sludge, so anaerobic digestion. Okay, hydrocarbons are used to make polymers. Polymers are used to make plastic bags. In 1 year, 8 billion plastic bags were used. The next year, there was a charge for plastic bags and only 1.3 billion plastic bags were used. Calculate the percentage decrease. So 8 minus 1.3, 6.7. So we're looking at percentage decrease. Divide that by 8. Multiply that by 100. And that should give you 84%. 3.4, oxides of nitrogen are pollutants formed in car engines. So oxides of nitrogen, that O could be 2, that could be 3. So we just put the letter X there to say oxides of nitrogen. Give one problem oxides of nitrogen cause. Well, there's 2 things that you need to be aware of. One is acid rain and the other one is respiratory problems. I'm going to go for acid rain, easier to write. I always say to my students, work smart, not hard. 3.5, here's your graph, oxides of nitrogen produced from 1986 to 2016. It says, why do we have an increase and then why do we have a decrease? Well, the reason it increased, it's because there was probably more cars, a bit obvious. Why would it decrease? Because cars were fitted with catalytic converters. So you can say use of catalytic converters or improved efficiency of car engines. You can say there's more electric cars or more hybrid cars. Or you can even say people are using public transport, or more people are walking, or more people are cycling. I'm going to go for what's on the spec. Use of catalytic converters. Question 4, again, this is a required practical, and it's salt in water. So you got 4 water samples, A to D. Record the mass of the dry evaporating basin. Pour 25 centimeter cube of water, sample A. Place evaporating basin, 10 minutes. Record the mass, basin and contents. Repeat with water sample A 3 more times and repeat the whole thing with B, C and D. So, what type of variable is the mass of dissolved substances? So a student investigated the mass of dissolved solids in 4 water samples. So that we're measuring that. So dependent. So remember, independent, the way to remember is I What am I changing? I change. Dependent, measure, control, keep the same. The method produced an error in the mass recorded in step 4. Suggest what caused the error and how could the error be avoided. Now the error is record the mass of the evaporating basin and contents. So here you can say not all water had been removed from the sample, which means that that would be added on to the mass. Okay, so mass included water, this water there, so mass included water on the bottom of the basin. Whenever you're given a diagram, always analyze it carefully because most of the time it's hinting the answer. So how do I avoid that? Well, I need to dry the bottom of the evaporating basin. Calculate the value x. So I've been given the mean, just need to work backwards, get the value of x. So I do 0.22 plus 0.23 plus 0.2 plus x. I divide that by 4 and I get 0.21. So rearrange, so you do 0.21 times 4 equals whatever that number is plus x. Rearrange and you should get 0.19. So that is 0.19. Which water sample has the greatest range, the biggest difference, high to low? So for each row, find the highest value, the lowest value, work out the difference. And you're looking for the row that has the biggest difference. So straight away I can see, well, these numbers are fairly close. So if I have a look here, highest, lowest, highest, lowest, that's more or less the same. That's more or less the same. So if you subtract these two numbers, get 6, take away 0.45, that gives me a range of 0.15. Highest value is 0.91, lowest value is 0.79, 0.91, take away 0.79, that gives me 0.12 as a range. So the highest range is this. So water sample C, and the answer, the actual reason is there's a biggest difference between the maximum and minimum value. Or you can here just calculate the range. You should still get a mark, which is what I've done there. So biggest difference between the highest and lowest value. Okay, water companies measure the volume of water used by households in cubic meters. 25 centimeter cubed of a different water sample contained 0.16 gram of dissolved solids. Calculate the mass of dissolved solid in 1 meter cubed. 1 meter cubed is 1,000 decimeter cubed. Give your answer in standard form. So 25 centimeter cubed contains 0.016 grams of dissolved solid. I'm going to convert that to dm cubed. So 1 dm cubed is 1,000 centimeter cubed. So 25 over 1,000 will give me dm cubed, which is 0.025 dm cubed. And then it says 1 meter cubed is 1,000 decimeter cubed. So decimeter cubed to meter cubed, I will divide by 1,000 again to get to meter cubed. So that will give me 0.00025 meter cubed. Right, so that means when I have 0.00234 meter cubed, I have 0.016 grams of dissolved solid. So then it says, now let's go back to the questions. Calculate the mass of solid in 1 meter cubed. So 1 meter cubed. This is what we need, question mark here. So, concept of ratios. How do I go from what number do I multiply this number by to get to 1? So I do 1, divide that by that, and that should be times 40,000. So that number multiplied by 40,000 gets me 1. Whatever I do on the left hand side, I need to do on the right hand side. Times that by 40,000 also. So when I do 0.016 times 40,000, I get 640 grams. That's my answer. There's more than one way to do this. I prefer to do it this way. I like to go through it in a logical way. So I'll go from centimeter cubed to decimeter cubed, then to meter cubed, because I don't want to make any mistakes. And then I get my answer, which is 640. This question is about crude oil and alkenes. Okay, so organic chemistry. Describe how crude oil is formed. Well, crude oil is formed from plankton. What happened to it? Buried in mud. For how long? Over millions of years. That's it, 3 marks. Describe how crude oil is separated into fractions by fractional distillation. First thing that happens, crude oil is heated. It's actually heated to about 350 degrees Celsius, but you don't need to mention that. If I heat crude oil, it will evaporate, or it will turn into gas. So crude oil is heated, it evaporates, okay, and turns into gas. Then remember your fractionating column, there's a temperature gradient, cold at the top, hot at the bottom. Crude oil vapor enters the bottom of the column, and then it starts to condense at the relevant boiling point. So the gases condense as they move up the column. And you can say that fractions, so remember every single gas that's condensing is a fraction, and these fractions have different boiling points. You've got boiling points of 3 alkanes. What is the general formula for alkanes? So this is great. So even if they don't have to give you this, because you still need to know it, but if you don't and you've forgotten it, you can work it out. So if you have a look, let's look at that, 5. If I double 5, 10, add on 2, I get 12. So the general formula, N is the number of carbon atoms. I double the number of carbon atoms and I'm adding on 2 hydrogens. That's your general formula. Explain the pattern, the trend in the boiling points of alkane. So I can see that the boiling point is increasing as the number of carbon atoms increase. Why is that? It's an explained question, so there needs to be a why, the science behind it. It's because the intermolecular forces are increasing. Intermolecular forces are found between different molecules. So there's C5H12, there's another C5H12, there's another C5H12. There's intermolecular forces, so forces that exist between the different molecules. These forces are weak. As the alkane molecule gets larger, you end up with more intermolecular forces, which is why the boiling point increases. Within the alkane, you have covalent bonds. Between different alkanes, there's intermolecular forces which are weak. Okay, so the boiling point increases as the number of carbon atoms increase. Intermolecular forces are increasing as the size of the molecule increases, which is what I've just mentioned. As the alkane molecule gets larger, you end up with more intermolecular forces. So intermolecular forces are increasing as the size of the molecule increases. Okay, looking at the properties of alkanes, this is the method. Pour C5H12 into a separating funnel, open the tap, stop the timer when it reaches line X, repeat with the other two alkanes. The level of C5H12 takes 6.4 seconds to reach line X. Predict the trend. So obviously that's looking at the runniness. So you should all know already that as the alkane molecule gets larger, the viscosity increases. In other words, it becomes less runny. If it's going to be less runny, it's going to take longer to reach line X. Okay. You also need to know that as we go down, as the alkane molecule gets larger, they become less flammable. Obviously, that's not relevant here. But so the trend is the time should increase because the viscosity increases. If you have high viscosity, it's less running, it's more gooey. If it has a high viscosity, it's less running, it's more gooey. And if you've got less viscosity, then it's more runnier. An alkane that has a lower viscosity is a greater fuel. It's a good fuel because it's highly flammable. Okay, so next question, looking at the Earth's atmosphere. So the greenhouse effect happens in 4 stages. So you need to know this for physics and chemistry. So let's just have a look at the 4 statements. So shorter wavelength, longer wavelength. So shorter wavelength radiation enters the atmosphere. That's the first thing that happens. Radiation is absorbed by the Earth. Yep. Longer wavelength radiation is emitted. Carbon dioxide stops longer wavelength radiation from escaping. That is the greenhouse effect. So, in that order, let's find the correct box. So it should be DBCA. That's your answer. Figure 6 shows how the percentage of CO2 in the Earth's atmosphere changed over 4.6 billion years. The mass of gas in Earth's atmosphere remains constant. Determine the maximum mass of CO2 that was in the Earth's atmosphere. So maximum, let's go to the maximum, read that value off. So that should be 90. That's 96. So 96% of 5.15 times 10 to the power of 18 should give you 4.94 times 10 to the power of 18. Describe the processes that have caused the main changes in the percentage of carbon dioxide in the Earth's atmosphere over the last 4.6 billion years. And it says use figure 6. So you can see that during the first billion years of the Earth's existence, the CO2 levels have increased, and we know that the reason behind that was the intense volcanic activity. So remember, this is present day, so we're looking at, this is when the Earth existence began, okay? So first billion years, CO2 levels increased due to volcanic activity. And then we can see that, so that's from 4.4 to 2.7 billion years. 4, 6, there, roughly. So from 4.4 to about 2.6 or billion years ago, CO2 levels decreased. So why is that? So we know that at that time, water vapor, water in the gas form, condensed to form oceans. The CO2 dissolved in the oceans. And then you can see from about 2.6 to 1.7 billion years ago, CO2 levels decreased further. So 2.7 to 1.6 roughly billion years ago, CO2 levels decreased again. And the reason, remember, this is what happened next. Plants evolved. And plants took in CO2 for photosynthesis. Okay, so that led to the reduction in CO2. And then what you can say is, so present day, so over the past 100 odd years, CO2 levels have gone up due to human activity, obviously burning fossil fuels, as there has been an increase in burning fossil fuels, or you can even say the Industrial Revolution. But that's sufficient for 6 marks. This question is about equilibrium. Describe how a reaction reaches equilibrium. So this is when a reversible reaction occurs in a closed system where the forward and reverse reaction occur at the same rate. So remember your reversible sign? Yeah. So when a reversible reaction occurs in a closed system or a sealed system where the forward and reverse reaction occur at the same rate. Nitrogen dioxide gas reacts to form dinitrogen tetraoxide gas. The reaction is reversible. This is the equation. Explain the effect on the equilibrium position of increasing the pressure. When you have a question looking at pressure, you need to go back to the equation and look at the number of moles of reactants and the number of moles of products. So here, look at the number at the front. That is 2 moles of nitrogen oxide reacting to give you, there's no number there, so that's 1 mole of dinitrogen tetraoxide. So the rule is, if you increase the pressure, the equilibrium will shift in the direction of where you have fewer moles. 2 moles there, 1 mole there. So the equilibrium will shift towards my right. Okay, so let's put the answer together. So we say the equilibrium shifts to the right hand side. And then you say the reason behind that, explain. So why is it shifting to the right? Because there are fewer moles on the right hand side. Final question, you've got the change, so you've got a graph, shows us change in percentage of dinitrogen oxide and the equilibrium mixture as the temperature of the equilibrium mixture is changed. Explain the effect on the equilibrium position of increasing the temperature. So the percentage of dinitrogen tetraoxide. So as the temperature increases, the percentage of this is dropping. Okay, so that means the forward reaction is exothermic. So you're increasing the temperature, the percentage of dinitrogen tetraoxide is falling. The forward reaction is exothermic. If the forward reaction is exothermic, the reverse reaction must be endothermic. Okay, so if I increase the temperature now, I can't have the reaction proceeding in the exothermic direction. The temperature needs to drop, so the reaction, so the equilibrium, sorry, shifts to the left-hand side. Why? Because the reverse reaction is endothermic. So the percentage of N2O4 would decrease. Okay, so remember Le Chatelier's principle, so equilibrium position, is high tier only. It is a challenging topic. Students do tend to struggle with this, but just remember that when you have a pressure related question, count the number of moles. The equilibrium position will shift in the direction of fewer moles to counteract that change. And if your forward reaction is exothermic, the reverse is endo, or if your reverse is exo, your forward will be endo. I hope you found that video useful. Hope to see you soon with another video.